do the project for my exercise class, and there are some doubts that I came across, and I didn't want to just write them down, so I'm going to explain them in this video itself. So the first thing I had a question about was let me open it, was the class known as Dataset. Basically, I did not actually fully understand what a framework is. So what actually happens is, when we are going to train a machine learning model, we use frameworks to simplify things, to abstract things. So for example, if you have a ReLU function, instead of having to write all the mathematical calculations that happen behind it, you just call torch and say torch.nn.relu. So the abstraction completes all of it. Now the issue that I was facing is, I was kind of confused about what the dataset class and the data loader is. And it turns out that once you actually import the dataset, so for example, here we have a training labels.csv, so the training data, and we have labels.csv. Once you import this, you just get the CSV file names. You can split these according and just use these since they're linked with the images already. Since they've already been validated, this can be used, and you can just split this into train, test, and validation. I mean, maybe I'm confusing the validation word up, but anyways, once you have done that, what you could do is you can just pass this entire thing, you can load it and pass it into the dataset class. Now the reason that we need a dataset class is, whenever you have any sort of data and you need to pass it to a model, the model takes a specific type of data into it, so it takes only a specific format. In this case, since we're using TensorFlow, it will be a PyTorch tensor. No, we're actually using PyTorch, so it will be a PyTorch tensor. So the dataset class, what it does is, it is mainly used to convert the normal data into a PyTorch tensor, and then you use the results of this. So you use this PyTorch tensor in the DataLoader class. So first of all, there is the dataset class, and then there's the DataLoader class. The output of the dataset goes into the DataLoader, and the output of a dataset is a PyTorch tensor in this case, since we're using PyTorch as our framework. There was also something else. Let me guess. Yeah, if you were using any other framework, so for example, if you're using TensorFlow, then you would of course use a data class that would return a TensorFlow tensor instead of a PyTorch tensor. So you would have to adjust that accordingly, and obviously TensorFlow has its own way of doing it. One additional thing that the dataset class is always, or most of the time, used for is to make changes to the data itself. So for example, if you want to maybe normalize it, or maybe change the pixel values a bit, maybe crop the image a bit, or something of the sort. This is not exactly augmentation, but rather simple changes to the data. You can use the data set class for this as well. And after that, once you get your tensor, you pass it down into the data loader. What this data loader does is it splits it decides on how to split your data, and it also efficiently tries to batch it up into smaller batches so it can be processed or multi-processed at the same time. It also reduces workload somehow, like I'm not exactly 100% sure how it does that, but it basically reduces workload and forms batches of your data so it can easily iterate over them and train the model with it. So I guess that is pretty much all I wanted to explain right now, because it was all to do with the dataset as well as PyTorch. It was just kind of confusing me due to the fact that I did not really pay much attention to it before, and now that I did have to come across it, it seemed pretty weird. But anyways, oh yeah, another thing. So if you were to not use any frameworks at all, let's say you wanted to implement this on your own. So normally, like I mentioned at the beginning, you would have torch.nn.relu, or maybe convolutional 2D, or maybe CNN or something, maybe a sigmoid function. You just write torch.nn.something. So maybe you have a class for CNN, and you just write torch.nn.conv2d or something like that. Or maybe you just write the same thing. So maybe you write here relu, or maybe you wanna write sig. I don't know how you write that. Maybe it's sigmoid 2D or something. I don't know, just sigmoid. So you do this. That's it. But let's say you're not using a framework, you would basically have to remove this. So PyTorch does not exist anymore. So you're removing all of this, and then you would have to define what's a sigmoid, what's a ReLU, and what's a convolutional 2D network. So for ReLU, you would have to do all the matrix multiplication and everything else manually. You'll have to define it in a function, and then you will have to specify it according to your specific dataset. The thing that PyTorch makes easy for us, or any framework makes easy for us, is the fact that you don't need to do all of this manually. So you won't have to just get all of this data into a specific format that your function, your convolutional function, or your ReLU function, or sigmoid function takes, but rather it just uniformly sets it up such that you can easily throw it into any of those functions and get the expected output from it. So you don't have to manually figure out, okay, I'm supposed to do this for this, and I'm supposed to do that for that. It just takes a lot of the manual work, and instead allows you to just write torch.nn.convolution 2D, or ReLU, or sigmoid, anything. I mean, one more thing would be that if you would try to do it manually, it would take a lot of time, but it would help you learn a lot of things, because then you would know exactly what's going on in the background rather than just writing torch dot and that's it. Because once you do it manually, you know exactly what you're doing. You know what the data is, what you're feeding into it, and what the outputs are expected to be, and how you should feed the data to it so it gives you the expected results. It sounds quite complicated, but it really isn't, because it's just data, I guess. Anyways, that should be it. Alright, that's it.